Alright, so if you're still confused with the root 2 1 1 and 2 root 3 1 thing that we did on the previous page, here we go. So we are going to apply that, then you'll see how handy it is and make more sense hopefully. So here we go. First example, find the exact value. So don't do any rounding, except if you end up with a nice number like 1/4, then you can write that as 0.25. That's totally fine. Okay, so find the exact value trig ratio of the following angles. So that means if angle theta is 135 degrees, what is sine of this? So what is sine 135? So if you look at this, let's do this. I know some of you say, Cheng, well, you're stupid. Use a graphing calculator to do sine 135. Why don't we just do this? Sine 135. Can you tell me what is the exact value? So even if you're writing down the whole thing first, there might be more digits that come after this. Okay, and this is not an exact. Exact means exact. Okay, so if you have previous experience with this, knowing that, oh, this is corresponds to some fractions, some rational numbers, then you can just write that out, but I'm stupid. So let's do this here. And first thing is, of course, to sketch this so that we have an idea what's going on. So 135. Now, if you look at this, you will probably think, isn't this something like we did at the beginning of class today, or at the end of the lesson last day, or at the end of the previous lesson? Well, kind of, but well, the difference is if you look at this, we don't know the coordinate of P. Let me sketch this, then that would make sense. 135, so this is 90, 135 is somewhere here. So this is angle theta, which is equal to 135. Now the question is, what is sine 135? What is cosine 135? What is tangent 135? Okay, so we are going to do pretty much the same thing. Make a triangle. So if you look at this, now in order to find all those trig ratio, the SOHCAHTOA stuff, we need to know the opposite, the length of the opposite, adjacent, and hypotenuse. Then we can figure out everything. However, if you look at this, do we know the length of each side? No, we don't. So what do? Have a look. If this is 135, what is this angle here? Okay, so 180 subtract 135. That gives you 45 degrees. So 45 degrees. We know the sum of the internal angles of a triangle is 180. If this is 90, this is 45. That means this is also 40. Sorry, I mean 45. Now, if you look at this, do you remember dealing with something like 90, 45, 45? Okay, so look at the previous slide. Here, 90, 45, 45, then the corresponding lengths are root 2, 1, and 1. So the length here is root 2 across from the 90 degrees, so root 2 here, root 2, and 1, and 1. One for this side, one for this side. Now the rest of the question is easy. Okay, so now doesn't matter. You can do sin. You can start with sin, cos, or tan. So let's do sin. So instead of saying sine theta, we know what theta is. Let's just plug in the actual value. So sine is opposite, which is 1, over hypotenuse, root 2. Bingo, done. Okay, so now if you still don't know what the heck is going on, how come this is the answer? Well, first, this is an exact value. It's not a decimal. Now let's plug this into your calculator. 1 over root 2. 1 divided by root 2, enter. Oh my, they are the same. Sine 135 is the same as 1 over root 2. Sine 135 is the same as 1 over root 2. Make sense? Now let's finish this up. Cos 135 degrees. So cos is, I'm not going to refer you to your formula sheet so you know where to look for SOHCAHTOA. So cos is adjacent, which is 1 over hypotenuse, which is root 2. Now, if you quickly enter cos 135 in your graphing calculator, what do we get? Cos 135, enter. Wait a second, we get a negative number. What's wrong? Remember, even though the length here is 1, because it is on the negative side of the x-axis, we have to put the negative sign. So this is actually negative 1. Negative 1. So now if you do negative 1 over root 2, we did that here already. Well, not here, sorry. Negative 1 divided by root 2, enter. Now they are the same. Remember what I said at the beginning of class today? That you need to keep track of the sign. So even though the length is 1, but in terms of the coordinate, it has a negative value. Okay, so tangent 135 is opposite over adjacent. 1 over negative 1. 1 over negative 1, that gives you negative 1. Okay, so this one you can cheat a little bit. Obviously, this is an exact value. So even if you cheat by using your graphing calculator, tangent 135, close bracket, enter, that gives you negative 1. At least if this is a quiz or test, you will get, well, 1/3 of the marks. Is that what you want? Okay. Alright, so I hope it is making a little bit more sense to you. Anyway, let's do another example. So this one, theta is 240 degrees. So basically what the question asking is, what is sin 240, exact value, cos 240, exact value, and tan 240. Okay, so whenever you see exact value, then you might want to do this. So 240, 90, 180, 240, somewhere here. So this is theta. Okay, and again, we don't know the coordinate of a given point P, so we cannot look at the coordinate and then figure out the width, the height, things like that. So if you look at this, at least we can fill in all the information. So if this is 240, what will be this reference angle be? So this is 180. 180 plus what gives you 240. So that means in this case, your reference angle or just this angle is 60 degrees. So that is 60. And if this is 60, we need 30 degrees here, so that I have 90, 60, 30, which add up to 180. So this is 100, sorry, this is 30 degrees. And of course, we're going to apply the same idea, except this time we are dealing with 90, 60, 30. If you want to call that 90, 30, 60, doesn't matter. So look at what we figured out on the previous slide. If it is 90, 60, 30, that means the corresponding lengths are 2, root 3, and 1. 2 for this, root 3 for this, and 1. So 2, root 3, and 1. So 2, bear with my OH, root 3 is 4, 60. So this side is root 3 and this side is 1. Now we know the lengths of opposite, adjacent, hypotenuse, and this time I'm not going to trick you. This is in the negative territory of the x-axis, so give that a negative. Even though the length itself here is 1, but we need to keep track of the sign so that we don't screw up the cast and the trig ratio. Okay, so this is a special case with 90, 60, 30. Now we know all the lengths, so we can quickly fill in the information. So sine 240, cos 240, tan 240. If you know the angle, you have to specify the angle. You cannot just say sine theta or cosine theta. Nope. Okay, so sine opposite over hypotenuse. So root 3 over 2. Root 3 over 2. I know this should also be negative. Oops, wrong color. How did I figure out that I screw up? Because if you look at that, CAST, only tangent is positive. Alright, so that's how I figured that out. Okay, cos 240 adjacent over hypotenuse, so negative 1 over 2. Okay, and then tangent opposite, negative root 3 over adjacent, negative 1. They cancel out, so that gives you root 3. Some of you may say, Chang, well, you are experienced, so you realize that for an angle in quadrant 3, sine would be negative. So if you want to double check your work, you can do this. Sine 240, clear, sine 240, that gives you a negative number. So even if you miss this, then when you check your work, you'll still realize that, oh, there's a negative sign. It's not likely your calculator would get wrong, so you know that somewhere there should be a negative. Okay, so same thing here. You can check your work here, you can check your work here. Alright, so now I'm not going to do this one because the answers are already on the PDF file in another folder. So I'll just skip this and then move on to the next question. Well, but definitely try this out. Alright, so next one. Actually, our last example here. I'll do both part A and part B with you guys. So if you look at this one here, solve for angle theta. What is the angle that when you do cos, that will give you this value? Okay, so here we are being nice to remind you guys that use your calculator, use the CAS rule, but for your unit test assignment, we won't be, well, at least I won't be that nice to remind you. Okay, always apply CAS. Okay, so now before we do the work, before we actually work out the value, so let's quickly sketch this. Some of you might be wondering, Chang, why do we want to sketch this out? Isn't this like the first thing we did at the beginning of the lesson today, that we simply take the inverse and then we can find the angle? Absolutely. Then let's do it your way. Alright, so at this point you don't have to worry about tangent and sine because you are just given the cosine. As long as you can figure out the angle theta, that's all you need. So let's do it your way. If cosine theta is this, to find the angle, that means we do the inverse function. So inverse cos of, in this case, negative root 3 over 2. Alright, so let's plug this into your graphing calculator. Clear this. Second, cos to get the inverse, negative root 3, moved it out of the square root, divided by 2, close bracket, so negative root 3 over 2, and we end up with 150 degrees, so that's nice and easy. 150 degrees. So that means if your angle is 150 degrees, that will give you this trig ratio. You can double check your work if you want. Cos 150 gives you exact same value of negative root 3 over 2. My question for you guys is, are we done? Hopefully you will tell me that no. We specify cas here. What's cas? So in this case, if you are familiar with cas, then you will know that cos is negative. When do you get cos negative? Cos is negative here and here. We have, so that means we should have two answers. We have 150, which is here. That means there should be another answer here. Alright, so how do you figure out the answer? Of course, we need to draw that. Okay, so if you look at this one, cos adjacent over hypotenuse. So if you look at this one here, we know we have one answer here in quadrant 2. That's angle theta, that's right angle triangle. So now if you look at this, adjacent is root 3. Well, you know what? I should keep it consistent with the color because there will be quite a bit of join. Root 3. And then hypotenuse is 2. What's the height here? Who cares? Right? So now if you look at this, and of course this is negative x, so give it negative. But from previous example, you know that, or from here, from the cas rule, you know that you can also draw it in a different way using the exact same information. You can have a triangle here. The adjacent is still negative root 3, and then the hypotenuse is still 2. That's angle theta. Okay, so if you just look at the green one here, that will give you exact same value. Alright, so if you look at this, if this is 150, what's your reference angle? Your reference angle here would be, let me use a different color. Your reference angle here is just this, 30 degrees. Because 150 plus 30 gives you 180. So that means this reference angle is 30 degrees. Now if I ask you, what is the angle of this thing? Then you will say that it is 180 plus 30. So if you don't want to confuse yourself, let's jot down this. So the first one we can, I mean there's nothing wrong if you keep the same, but if you are thinking that you are getting confused, let's do this, theta 1, theta 2. First angle, second angle. If you want to leave that as theta, theta like this, that's absolutely fine. So theta 1, theta 2. So theta 2, this one here, 180 plus 30. So 180 degrees plus 30 degrees. So that gives you 210 degrees. For those of you who are wondering, Cheng, are you sure you did that correctly? Why don't we do this? Let's do cos 150 and do cos 210. You should come up with the same answer. So let's do this. So we did cos 150 already. So let's do cos 210. Look at that. Same value. And what is this? So if you do negative root 3 over 2, negative root 3 divided by, 3 over the bracket divided by 2, that gives the same. So that means this is the same as negative root 3 over 2. Okay, so now you can see that. Well, I hope that makes sense. Why? Because cos is negative in quadrant 2 and quadrant 4, as we figured out. So let's do the last one here. Okay, so this one we are going to do it in a slightly different manner because the question is asking, or we have to use the special triangles thing. But anyway, if you look at this, so if you look at this, sine is positive. Where would sine be positive? Here. So that means, again, we should have two answers. I hope applying the CAS and this kind of things has become your second instinct. Let's sketch this. So if you look at this, we have sine opposite over hypotenuse. So that means for our triangle, so one for opposite, so something like this. This one, hypotenuse is 2. And of course, we can use Pythagorean theorem to figure out this, but the question says use special angles, use special triangle. Usually, we would not be that picky. You can use Pythagorean, so a squared plus b squared equals c squared, and then take the square root and figure out this. But let's apply that. Use special triangles. What do I mean by special triangles? The 90, 45, 45, and then the 90, 60, 30. So if you look at this, which one is this? Because we don't know what angle we're dealing with. We know for sure this is 90. Is it going to be 45, 45, or is it going to be 60, 30, or 30, 60? So let's look at this. So if it is 90, 45, 45, you have root 2, 1, and 1. Okay, but we don't have root 2 here. So instead, we have 2 and 1. So that means it should be this one. 90 degrees would be 2, 60 degrees, the corresponding sign would be root 3, and 30 degree would be 1. So 2, root 3, and 1. 2, and then root 3. Root 3 would be for 60 degrees. So that means this side would be root 3. Look at this, 2, root 3, and 1. So the side opposite to the angle 60 has a length of root 3, so that means this is 60 degrees. The side with a length of 1 is opposite to 30 degrees. So what does that mean? That means this is 30 degrees. So that means this is 30 degrees. And that means this is 60. Sorry, it's a bit messy. So what does that tell you? Our first answer is angle theta is 30 degrees. Okay, and then if you look at this, I mean, you can actually do it the same way like what we did for the last question, but just to answer the question here or follow the instruction, use special triangles. We know that we are going to have another answer in quadrant 2 because sine is positive over there. So let's do this. Same thing. 2, 1, and 3. If this is 30 degrees, that means this must be 30 degrees as well because they are mirror image of each other. But now I'm not, this is the reference angle and we already have 30 degrees. So for this one, we are talking about this. What is this angle theta? If you want to distinguish this one from the previous one, you can call this theta 2. So that means call this theta 1 and theta 2. What is the angle from here all the way to here? So it is 30 degrees short of 180 degrees. So that means you do 180 minus 30, and that gives you 150 degrees. Because if you look at this, 150 plus 30, that gives you 180. So that means my theta 2, this one up to here, is 150 degrees. And again, you can check that. If you do sine 30, sine 150, they give you the same value, which is 1/2. So let's quickly do this. Sine 30, sine 150. Sine 30, 0.5, 1/2. Sine 150, same thing. And of course, 0.5 is 1/2 is the same as 0.5. So this is correct. All right. So the last thing, questions you. Oops, sorry, I lied. We are not done. Okay, so promise this is the last example. All right. So solve for angle theta, and angle theta has a range somewhere between 360 and 0 degrees, and you can, lucky you, so approximate. So and so that means you can take advantage of your graphing calculator, but keep in mind you need to do the rounding correctly, round it to the nearest degree. So anyway, let's do this. So I hope you all know what to do, even though this is the first time we do this example. So if you look at this, if we know the tangent theta already, so that means we can do this. The inverse, in this case, the inverse of tangent of 1.5689. Okay, let's do it on your graphing calculator. Second 10, 1.5689, 1.5689, enter. So round it to the nearest tenth, so that gives you 57 degrees. So that gives you 57 degrees. My question is that it? Hopefully you told me no. Why? Because what are we talking about here? So if you look at this, tangent is positive. When is tangent positive? Everything is positive here. Tangent is positive here. So that means we should have, once again, two answers. So we got the first one, 57 degrees. So that means we have already covered this scenario. What about this one here? Right? So if you want, you can do some sketch here to help you. So that means this is angle theta. And then another one, we should have another angle here. So this would be another angle, theta. So again, if you want to keep track of which one's which, this is the second one, and this is the first one. So we already got this one. We know that this is 57 degrees. What would be this whole thing here? If the reference angle is 57 degrees here, that means the reference angle will be 57. 180 plus 57, that will give you theta 2. 180, I meant, plus 57 degrees. So add them up, that gives you 237 degrees. So again, you can double check your work. Let's do this. So we are talking about tangent here. So tangent 57 should give you this. Tangent 237 should give you that. Let's do this. Tangent 57. Let's clear this. Tangent 57 gives you that. Well, some of you may argue with me and say, Chang, it's not the exact value that we got here. This one has been rounded. Okay? And then let's do tangent 237 degrees. Tangent 237, exact same value. So that means we were correct. Okay, last example. Again, I hope you can pause for a few seconds and then finish this up yourself. So assume you have done that. So let's do this here. You don't have to sketch it first. You can just work out the first angle and then sketch it to help you find another one. Or if you want to play safe, it is always a good idea to sketch something because, well, at least for me, I'm a visual type person. So anyway, this is sine. So let's do the inverse sine of negative 0.2864. So clear our calculator. Inverse sine of negative 0.2864, 2864, close bracket, enter. That gives you negative 17 degrees because we want to round it to the nearest tenth, sorry, nearest whole number, nearest degree. So negative 17 degrees. Okay. I know there's another answer out there, but what does it look like? How to figure that out? Well, maybe you want to take advantage of the cast. So if you look at this, sine is negative. Everything is positive. Sine is positive. Tangent is positive. So that means sine would be negative. Cos is positive. That means sine would be negative. So that means we have two answers. Here and here. Now you cannot leave that as negative 17. Why? We'll do this quite often in Math 3-1 because the answer of our the range for our answer is somewhere between 0 and 360. Is that somewhere between 0 and 360? Nope. So that means we have to convert that into something in that given range. So negative 17 degrees would be starting here, going down. So this. So that means this one, theta 1, would be 17 degrees short of 360. So 360 minus 17. So 360 minus 17. So that gives you 343 degrees. And then for our second angle, we know that it would be here. So my angle theta 2 would be this. If we know this is 17 for this reference angle, that means this reference angle would be the same because they are the mirror image of each other. So that means this one would be 17. What is this angle? 180 plus 17. 180 plus 17. So theta, oh my, theta 2 is 180 degrees plus, I don't know what's going on with my laptop here, but let's quickly finish this. That gives you 197 degrees. 197, oh my. So if you look at, you can check these numbers on your graphing calculator. Sine 343 gives you this, which is the same as sine 197 degrees. Okay, the last thing is assignment. Have fun and enjoy. Send me an email, or when we have our tutorial or in class time, virtual class time, you can talk to me in class. Okay.